This video is going to focus on the learning target. I can name and write formulas for ionic compounds that include polyatomic ions. So what are polyatomic ions? Well, poly means many and atomic means atoms. So they're ions that have many atoms within them, but the whole unit itself just has one charged. So it's a charged group of two or more elements that are covalently bonded as a single ion. Sometimes we jokingly call polyatomic ions 8th grade girls. They go everywhere together. They can't manage to go anywhere without being together. So it's this little packet of elements that traveling together have a charge on them. Oftentimes in a name, you'll be able to tell that it's a polyatomic ion because polyatomic ions usually end in ate or ite, versus on the periodic table, and when we're using the periodic table, we end everything in IDE. The exceptions of this are hydroxide, ammonium, and cyanide. But luckily for you, if you're confused, there's a reference for you on the back of the periodic table. So on back of the periodic table that I handed you, I have a list of common polyatomic ions that you're able to use for your test on everything subsequent from there. So in this chart, you have the names as well as the formulas and the charge on them. So if you're confused, you can always reference this to try to determine if you think it's a polyatomic ion or not. Okay, the ones that are blue are just the ones that we more commonly see in our class, but the black ones are ones that we'll use as well. Sometimes I'd even say the blue ones are ones that you should kind of attempt to memorize because they're the ones you'll see so often. You'll want them kind of at the tip of your memory bank to be able to recall and pull them out. So for these problems then, if I was going to work on them, I do them the same as I would for normal ions, except now I'm using polyatomic ions. Okay, so sodium is Na, and based on where it is on the periodic table, it's a +1. Phosphate, though, then, if I look at the back of my periodic table, this is a polyatomic ion that is PO4, and it has a charge on it of 3-. So I figure out at what ratio they come together at, and I need 3 sodiums for every 1 phosphate to make it work. So this polyatomic ion is just a group of charge rather than just one element being charged. Calcium is Ca and has a +2 charge based on the periodic table location. Chlorate, if I look at the back of my periodic table, is ClO3 and has a 1- charge on it. So looking at that then, I need 1 calcium and 2 chlorates. So the way we show that we need 2 of that entire group is we put it in a parenthesis and then put the subscript on the outside. So that's indicating that I need this entire group 2 times. Down at the bottom then, to get the name from the formulas, Mg is magnesium, so that's easy enough. Magnesium is in a column that doesn't need a Roman numeral. NO3, if I look at the back of my periodic table, is named nitrate. And that's it for ionic. I don't worry about using the subscripts for any names. Fe is iron. And in this one, I am going to need a Roman numeral because iron is not in one of those first 2 columns. SO4, if I look at the back of my table, is called sulfate. Now, given the fact that each sulfate is a -2, and I have 3 of them for a total of -6, that means the iron is going to have to add up to 6, and since I have 2 of them, the iron charge is 3. Now, other than just the ones at the back of your periodic table, there is kind of an expanded list of polyatomic ions because depending on the ending, we can actually slightly change the polyatomic ion to be something else. So if you take the ones at the back of the periodic table and you change their numbers of oxygens, that changes the name. Okay, so for example, phosphate on the back of your periodic table is PO4. If instead you see a polyatomic ion that's PO3, that's called phosphite. So polyatomic ions that end in ites is just 1 less oxygen than the polyatomic ion that ends in ate. If 2 oxygens are removed, so phosphate is PO4, phosphite is PO3. If you see PO2, that's called hypoite. So that would be hypophosphite. If instead of removing, I gain 1 oxygen, that's called per. So perphosphate would be PO5. In all of these cases, please notice that the charge didn't change. All that's changing is the number of oxygens. In order to change the charge, we can do that, and that's the last one on this list. That's messing with hydrogens. Okay, so what I would do for now is I would use this slide in this PowerPoint as a reference as I'm trying to name things. Okay, and you can use it as a resource for yourself as well. So here's an example of how the naming convention applies. Right, so if I'm using chlorate, on the back of your periodic table, you will find chlorate, which is ClO3 with a -1 charge. If that ClO3 was to gain 1 oxygen, right, if I plussed an O, then it becomes perchlorate. Same charge still, -1, it just has 1 more oxygen, now called perchlorate. If I were to subtract an oxygen, then I become chlorite. Okay, so 1 less oxygen, same -1, chlorite. If I were to remove another oxygen, now it becomes hypochlorite, still with a -1 charge. Okay. Using these, you would use them the same as you would use any ion. So if I was trying to name something or write a formula for something called like magnesium chlorite, magnesium's always Mg with a +2 charge based on the periodic table. Chlorate is ClO3, so chlorite is ClO2 with a -1. Based on canceling their charges, I see I need 2 chlorites to make this work. And you put a parentheses around it to show that that whole thing is happening twice. Okay. It's complicated only in that I have more potential ions, but it's really not hard. The tricky thing comes in when the fact that all of these names kind of end up looking a lot alike. Okay? So I could ask you about like magnesium chloride, right, which would be one formula. I could ask you about magnesium chlorate, which would be a different formula. So magnesium chloride is MgCl2, magnesium chlorate is MgClO3 if I wanted magnesium hypochlorite, right, that would be MgClO, and I would need 2 of them. So the naming can end up looking a lot alike, so you just have to be really careful. So as you start to begin to practice making ionic compounds, and especially making them with polyatomic ions, make sure you're using your periodic table and that you're also using this slide that has those name changes. And you can also see based on this video, this is why students say you just have to practice. You have to practice, 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 practice until you can do it without thinking too hard. Okay, so that's it for your video on polyatomic ion. Go ahead and try the quiz and have a nice night.